So I was digging through the data for today's explainer and wow, I stumbled onto something literally wild. Get this. Right now, nearly 50% of all new software code being written, it's packing severe security flaws. Half of it. But here is the truly shocking part. The culprit behind these massive vulnerabilities isn't some shadowy syndicate of hackers. No, the culprit is the exact technology that was supposed to make software development faster, easier, and better. Yep, we're talking about artificial intelligence. Welcome to the Explainer. Today, we're going to completely dismantle this whole myth around AI coding speed. And we aren't just throwing around opinions here. No, we're digging into the hard, undeniable data derived from an analysis of over 210 million lines of code from sources like GitClear. Let's dive in and see how the push for supersonic development speed might actually be building a massive technological trap for our future. Here's our roadmap for today. We'll kick things off with the illusion of AI speed, uncover a crisis called Comprehension Debt, explore some serious security nightmares, and look at the hidden human cost. Then, we'll outline how we actually fix this process and introduce the rise of the intent manager. All right, Section 1, the illusion of AI speed. So is AI actually faster? You know, the big marketing pitch for these AI coding assistants is that they make you flawlessly fast. You just plug it in and suddenly you're shipping features at light speed. But the data reveals a completely different reality. Let's look at a metric called code churn. Basically, this is the percentage of code that gets written only to get totally deleted or completely rewritten within just 2 weeks. Historically, this sat around 5.5%, but in the AI era, it's jumped up to 7.9%. That is a massive leap, guys. It tells us that instead of flying through projects, developers are actually getting stuck in this loop. They generate code, realize it doesn't quite work, and then have to rip it all out and do it again. It's the illusion of progress. So what's actually causing all this constant rewriting? Well, that brings us right to Section 2, the Comprehension Debt crisis. This is the silent issue that's kind of infecting codebases worldwide right now. Look, we all know about technical debt, right? You take a shortcut to hit a deadline, knowing full well you're going to have to fix it later. But AI has introduced something way more dangerous. Comprehension debt. Basically, it's this massive void between the huge volume of code that an AI generates and the tiny, tiny fraction of it that a human brain actually understands. This AI slop might pass your basic unit tests, sure, it might even look neat, but when your favorite app crashes at 2 a.m. or worse, leaks your personal data, it might be because literally nobody on the team actually knows how to fix the AI's logic. Honestly, it's kind of like thinking of AI as a blind contractor. Imagine you hire a builder and they execute a blueprint perfectly. Every brick is flawless. But the blueprint they used was actually meant for a completely different city. Different climate, different building codes, the whole shebang. The AI doesn't know why on database field was defined a certain way 6 months ago. It lacks historical context. It just matches patterns. So it builds the house perfectly. But then you open the front door and, surprise, you're staring straight into a solid brick wall. And you know, this total lack of context translates directly into horrifying vulnerabilities. Let's get into Section 3, AI code security nightmares. Just look at this data point. It's staggering. In 2024, we saw an 8x increase, an 8 times jump in duplicated, copy-pasted code blocks. Because developers are just so overwhelmed by AI-generated complexity, they're taking the easy route. Instead of doing the hard work to properly refactor old code to fit new systems, they just ask the AI, get a few new lines, and paste it right in. It's literally compounding the garbage in our systems exponentially. And here's the really terrifying reality. A lot of people think, well, you know, AI trains on the best code on GitHub, so it must be secure, right? Yeah, no, absolutely wrong. The internet is totally unfiltered. For every single piece of brilliant code out there, there are decades of awful, highly hackable, insecure repositories. The AI is just looking at statistical probability. And sadly, bad code is highly probable. The result? 45% of AI-generated code contains active security vulnerabilities. Almost half. Let's actually break down what those failures look like. AI is failing to prevent really basic hacks, things like cross-site scripting and login injections, nearly 90% of the time. And worst of all, we're seeing a 2x increase in hard-coded credentials. I mean, we're talking about developers literally just leaving passwords, API keys, and database access tokens sitting right there in the raw code. These are amateur, legally liable mistakes, and they're doubling in frequency just because people are blindly trusting the machine.
Now, a crisis like this deeply affects the actual people building the software too. That leads us to Section 4, the hidden human cost. Let's talk about the impact on developers.
This impact is devastating across all experience levels. Take junior developers. They are pumping out code faster than ever before, but when you look at randomized control trials, juniors using AI actually scored 17% lower on comprehension tests. They aren't building mental models of their systems. They're really just borrowing the AI's logic. Then you look at senior developers. Their productivity has actually dropped by 19%. Why? Because they're basically spending all day acting as highly paid garbage collectors. They're just endlessly cleaning up these mountains of flawed slop generated by the juniors and the AI. It's this classic factory floor dilemma. Imagine a factory manager who decides, hey, let's double the number of production machines to increase output, but then completely refuses to hire any more quality control staff. What happens? The existing QA team just gets absolutely crushed under the weight of defective products. That is exactly what's happening to engineering teams today. We're maximizing production while completely throttling quality control. Okay, so how do we get out of this mess? Let's dive into Section 5, fixing the development process. Look, AI is incredibly powerful if you use it right, but we have to fundamentally change the way we work. We absolutely need a massive paradigm shift here. Right now, developers view the code as the primary artifact. That's got to change. Step 1 is now writing the specification. Think of this as the project constitution. It's an unbreakable set of rules and logic, and it has to be written by a human. Only once that constitution is ironclad do you move to Step 2, which is setting up safeguards. And then, finally, Step 3, letting the AI generate the actual implementation. The code isn't the source of truth anymore. Your human specification is. And we know that enforcing rigid rules actually works. Take this for example. When developers use a strictly typed language, something like TypeScript, alongside their project constitution, it automatically catches logic and type errors generated by large language models. In fact, it catches 94% of them. Structure and strict boundaries, they are your ultimate safety net against AI hallucinations. Going a step further, we've got to train ourselves to treat AI as an unreliable dependency. You really shouldn't put AI directly into your main request path without a net. You need to set up circuit breakers. You know how the electrical panel in your house trips when there's a surge so your house doesn't catch on fire? Your system needs to do exactly that. Automatically cut the AI off if it starts generating overly complex or harmful output. This is exactly why organizations handling critical systems, like the creators of SQLite or even NASA, have such strict boundaries and sometimes outright bans on AI-generated code in their core environments. They know you absolutely cannot rely on probability when you need absolute precision. Which brings us to our final section, Section 6, Rise of Intent Managers. So if the AI is writing the code, what exactly does the human do? I love this analogy. Think of AI as a sous chef robot. It can chop vegetables incredibly fast, but you still absolutely need a head chef to guarantee the final taste of the dish. The AI is really just a signal amplifier. You give it brilliant architecture, it amplifies it. You give it lazy requirements, it multiplies the garbage. So human expertise in setting the recipe is actually becoming infinitely more valuable right now. We're seeing developers transform into what we call intent managers. This is the future job description. You aren't just going to be a code writer anymore. You're going to define the exact purpose of the system. You'll write those precise, unbreakable specifications. You'll set up the security guardrails, and you'll rigorously validate the logic before it ever touches a production server. Trust me, if you master intent management, you are never going to lose your job to an AI prompt. Which leaves us with a pretty fascinating, maybe slightly unsettling question to wrap things up. As we shift entirely over to managing intent and writing specifications, is reading raw line-by-line code soon going to be like reading ancient Egyptian hieroglyphics? Think about it. Decades from now, will the native language of computers just be a lost art, something understood only by the machines themselves, while we just casually hand them our blueprints? It's definitely a profound thought to ponder as we navigate this massive technological shift. Thanks so much for joining me for this explainer. Keep questioning the tools you use and stay focused out there.